There are more than 12,000 debris in the low orbits flying around.
We were aware of the fact it was debris, and we were hoping we would have no impact.
4 октября 1957 года с космодрома Байконур стартовала ракета и вывела на орбиту спутник Земли.
It's the 4th of October 1957, and the very first satellite, Sputnik, has just been launched. Nowadays, there are over 700 operational satellites orbiting above our heads, sending the signals for our phones, television, weather information and GPS. But there's a problem. Our current satellites are sharing space with the debris remaining from all of their predecessors, which, unlike Sputnik, haven't fallen back to Earth.
So imagine this satellite Eureka that's behind me. Imagine it having a collision with another satellite about the same size, provoking or giving thousands of new debris, each at least the size of a fist and more than 1 kilogram in weight, flying around the orbits and destroying other satellites.
In 2009, the expected happened, and the American Iridium satellite collided with debris from an inactive Russian satellite. The result? 2,000 more pieces of debris and the destruction of a $55 million satellite.
Something has to be done about this problem. Collisions between satellite and debris are bound to happen. And as one collision multiplies the number of debris and can create up to 2,000 additional debris, there's going to be an avalanche effect, and more satellites are going to be kicked out or destroyed in orbit.
A higher risk of impact means higher insurance premiums, and the cost of insuring today's active satellites is around $20 billion. More importantly, aside from the material costs, astronauts' lives are also at risk.
We were aware of the existence of debris when we were spacewalking. In a human spaceflight, we had really this ethic of not leaving anything in space, except if we had to for safety reasons.
The International Space Station has to frequently maneuver to avoid some 12,000 larger pieces of debris that are constantly monitored. These larger pieces of debris measure at least 10 centimeters wide, just like SwissCube.
After the launch of SwissCube, the Space Center decided to create a program to develop technologies that would help us remove debris from space. The challenge for Clean Space One is to go up there and rendezvous with SwissCube and then grab it and then bring it down to enter the atmosphere. So the technology is to bring that small spacecraft and have the rendezvous are not technologies that you can find off the shelf. At EPFL we're developing micro and electric propulsion systems, so systems of propulsion that push ions. There are several other technologies that will be needed because SwissCube was a 10 by 10 and Clean Space One won't be that much bigger. It's not a multi-million development, it's a university-based development. The second main challenge will be having a deployment of either a robotic arm or a deployment of a mechanism that will embrace or grab exactly SwissCube. At EPFL and at the Swiss Space Center, we do have quite a bit of heritage in terms of bio-inspired robotics.
So we will create a new family of satellites, new technology that will allow us to go up to space, to identify our satellites, to grapple them, to deorbit them, and maybe even in the future to bring them back to Earth.
We need to undertake something now. Like, exactly in the same way, we need to undertake something about the global warming. In a way, there's some similarity between the two problems. If we don't do anything, we'll have big problems in the future.